Hello everyone. Today we shall learn something about arithmetic progression. Have you ever wondered about what is meant by progression? Progression means as a sequence of numbers that follows a specific pattern. Now, arithmetic progression is a kind of sequence where the difference between each consecutive term is the same. Now, we have been seeing this schema in our lifetime also, where we look into certain patterns that we see in real life examples, in numbers and every aspects. So today in this class we shall learn this type of sequence which is following a certain kind of pattern in terms of its relationships. So before we move on, let me once again explain that in today's class, we shall be looking into what is the core concept behind arithmetic progression, where we see a sequence of numbers that is having certain kind of relationship, where the difference between them is having the same difference. Now, if you look into this example, 2, 6, 10, 14. Now, as I see the sequence, the first term started with the number 2, and it follows the progression with having a common difference 4. So each term is being progressively followed up by adding up a common factor. Now, this scheme is also applicable in reverse ordering too. So, arithmetic progression is a kind of concept in mathematics that is applicable to find out nth term. Now, for example, in a smaller dimension or in a smaller aspect, if you have been asked to find out what would be the nth term in a small sequence, or example, what would be the fifth term or the sixth term, it is quite simple for a common man. But let me ask you, if you have been given a sequence of numbers and if you have been asked to find out what would be the 100th or what would be the 1000th value in that progression, obviously mental aspect is not that as simple. For tackling such kind of aspect, we need to use certain formulae. Now, arithmetic progression derives a certain type of formula to find out the nth term in a sequence. We shall be looking into that. So, as I told you, arithmetic progression is a sequence where each term, except for the first term, is being kept on adding by a fixed number with respect to the previous term. Now, if you look at this example, 1, 5, 9, 13, 17, 21. Here the first term, A1, is 1. And each term successively is being followed by with a common difference 4. So, generalizing with the common progression, the first term is represented with the alphabet called A, and we keep on accumulating it as A plus D, A plus 2D, A plus 3D, etc. And finally, the nth term is A plus n minus 1 into D. Now, here n is been formulated with the numbers 1, 2, 3, 4, etc. and we substitute them accordingly in order to find out the answer. Now, as I told you, some of you might be thinking, if you are quite familiar with the mental calculation to find out the nth term, why do we need to go in formulas? What is the necessity of studying formulas? So this is what I told a while before. Now, at certain instances, when you are asked to find out the nth term in a longer progression, which is beyond a far limit, beyond a human calculation, at that time, application of formula would be always advisable. Say, for example, in a sequence 6, 13, 20, 27, 34, etc. It keeps on going. And if I ask you to find out what is the 102 termed, 102 termed in this sequence, you could easily find it out using the formula AN, where N stands for the nth term. So here in this example, N should be 102. So A102 termed in this progression sequence could be derived by substituting with this following parameters, where A depicts as the first term in the progression. Here it is 6 plus 102, where n is decided as the nth factor to be found out, 102 minus 1 into d, which is equivalent as the common difference between the two consecutive terms in the progression sequence. And there you go with the final answer. Now if I ask you to find out the sum of n terms within arithmetic progression, obviously that would be the accumulated sum of all the terms right from the beginning till the end, or in the reverse order also. So technically speaking, if we have generic terms like the first term called A, second term A plus D, A plus 2D goes on, and if you keep on adding all those things, that gives an accumulative sum, arithmetic programmatic sum of all the terms. So generally speaking, the formula to find out the arithmetic sum progression of a sequence of terms is Sn, sum of nth terms is equal to n by 2, where n decides the total number of terms in the sequence into first term plus last term. So there are two pivotal aspects. Now to explain this scenario, let me come with a practical example. Say for example, Kevin is a person who earns 4 lakhs rupees per annum. And annually he gets a salary hike of 50,000. I repeat, if Kevin is a person who gets an annual salary of rupees 4 lakh per annum and he gets a salary hike of rupees 50,000 per year, then what would be his total earnings at the end of third year? So in such cases, the formula of sum of finding nth terms could be put into right implementation. Now if you just use this formula, sum of nth term, the total salary acquired based upon in addition to the salary hike which is included in the problem. So after the end of first year, Kevin gets a salary of rupees 4 lakh, and then 50,000 is added on. At the end of second year, that keeps on. So you could have the provision of calculating it manually, but however, if we keep on using this formula, that is sum of nth terms. So the problem which I asked you is to find out what would be the total salary at the end of 3 years. So n here is 3. So the formula is 3 by 2, the whole divided by first term, 2a plus n minus 1 and d, because here the nth term is not at all known to us. So we are already aware that the nth term could be found out by a plus n minus 1 to d. So a plus n minus 1 to d becomes 2a, 2 times the first value. So 2 into 4 lakh plus 3 minus 1 becomes 2 into the salary hike, that is added as the common difference here. So altogether we get as 13,50,000 as the final value that Kevin will be earning at the end of tenure of 3 years. So this is just a small instance. So likewise, arithmetic progression has a pivotal role in finding out a good progression sequence, and its implementation could be used in real life for finding out answers on various aspects. I hope you have found this class interesting. We shall be looking into more aspects For the time being, I am Jimmy George, your tutor, signing off. Over and out.